Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, the atomic structure. Today we will begin with lecture 14 from the course, but make sure you have watched the previous ones before viewing this one. In the last lecture, we discussed about the radius of the Bohr's orbit, the velocity of the electron moving in the orbit. So we would be continuing our lecture, mathematical expression for Bohr's atomic model further. And today we will be learning how Bohr calculated the energy of the electron moving in the orbit. Why? Because Bohr said that in one orbit, the energy of the electron is fixed. The electron, it is not gaining or losing any energy. The loss or gain only happens when the electron moves from one energy level to another energy level. So if the energy of the electron is fixed, it must have some value, and let us find what is the energy of electron in the Bohr's orbit in this lecture. So the energy of an electron is the sum total of the kinetic energy plus the potential energy. And kinetic energy from your young classes also you know that is half mv square. The potential energy in this case of the electron is going to be the electric potential energy, and this is the product of the Coulomb's force and the orbit radius. The Coulomb force now you know is K Q1 Q2 by R square. So multiply that by R, you get K Q1 Q2 by R. We can write this also as Q1 to be Ze, the charge on the nucleus, and minus E, the charge on electron, that is Q2. So we have kinetic energy to be half mv square and potential energy to be minus kZe square by R. So we've put the values over here and we get the total energy. Now from the equation that Rutherford gave for the forces, that was mv square equal to kZe square by R square, right? So from this we can calculate what would be the kinetic energy also. Like if you are going to cancel out the common R, you are going to get this as mv square is equal to kZe square by R. So what we will be doing is that we will be putting the value of mv square over here. What would you get? Half kZe square by R, right? I hope that is clear. So we have the kinetic energy, which is half mv square, to be equal to half kZe square by R, and we are just going to replace the values. We get the kinetic energy to be half kZe square by R minus kZe square by R. So what would be the total energy? Yes, it is minus 1 by 2 kZe square by R. And now if you see the magnitude of the energy and the kinetic energy, both of them have the same magnitude, that is half kZe square by R. The only difference is the negative sign in the total energy. So we have kinetic energy to be having opposite sign to total energy. So total energy is minus kinetic energy. And how do we get this part? Just see energy and potential energy. So potential energy is going to be twice that of the total energy. So this is 1 by 2. So just divide kZe square by R by 2. You get as potential energy, right? So potential energy divided by 2 is energy. So we have the total energy to be potential energy by 2 and equal to minus kinetic energy. So this is a very important relation. This has been asked many a times in the questions. Even one of the exams where in a JEE advanced exam also this was being checked. Okay, so this is a very important relation. So please do remember this. Now we are going to just replace the value of R, the radius, from what we had calculated the value of R in the last lecture. So here the energy was minus 1 by 2 kz E square by R, and the value, the expression for R is n square h square divided by z km 4 pi square E square. Now the R was here in the denominator, so we have just reversed that, nothing else. So we get the energy to be minus 2 m k square z square pi square E4 by n square h square. Again, we are just going to separate out the constants, and the rest is z square divided by n square, right? And this all constants, they have been given another symbol, that is RH, which is the Rydberg's constant for hydrogen. And if you calculate the values, putting the value of mass to be 9.1 into 10 power minus 31, K to be 9 into 10 power 9, pi 3.14, charge on the electron 1.6 into 10 power minus 19, H to be 6.626 into 10 power minus 34. The value you will get for this all constants is 2.17 into 10 power minus 18. Okay, so the energy of the electron in an orbit becomes minus 2.17 into 10 power minus 18 z square by n square joule per atom. And if we want the energy in electron volt, this energy is going to come up to minus 13.6 z square by n square electron volt per atom. How have we got this? We have just divided the joule energy by 1.6 into 10 power minus 19, because 1 electron volt is 1.6 into 10 power minus 19 joules. Right? I hope you remember that. We have studied that also in some other lecture. And now if we want the energy to be in kilojoule per mole, then we have this as minus 1312 z square by n square kilojoule per mole. Okay, so these all values, they are important for you. You should learn them because this helps a lot in your problem solving. This would save lot of time. So please do learn all this also, and the value for radius and velocities also. The constant values, if you know, you are going to save lot of time. Okay, so please do learn them. And then for the ground state of hydrogen atom, Z is 1, N is 1, so would have the energy in the ground state of hydrogen to be minus 13.6 electron volt. Now another important thing which I want you to remember is the relationship between Z, N and E. What is that? Well, if I ask you how are energy and Z related, what would you say? That energy is directly proportional to Z square, right? So with the increase in the atomic number, the energy should increase, right? No, this is not the case. Why is it not? Because we have a negative sign before the expression, right? So if you increase, say we have first the Z to be 1. So this is going to be 13.6 multiplied by minus 1, right? And if we take Z to be 2, we are going to have 13.6 multiplied by minus 4, right? What is big, minus 1 or minus 4? Yes, it is minus 1, right? So we are minus 13.6 into 1, that is going to be more energy than when the Z is becoming 2. So with the increase in the atomic number, the energy is going to decrease. Okay, and similarly you can see that for N also. What is going to happen with the increase in N, the energy is also going to increase. Okay, I hope this is clear to you that with the increase in Z, the energy is going to decrease, and with the increase in N, the energy is going to increase again. So with the increasing distance from the nucleus, the energy is increasing and it is becoming less and less negative and moving towards zero. Fine. Okay. Now the different energy levels, they are not equally spaced even when we study about the energy. The energy difference between two successive levels does not remain the same as we move away from the nucleus. The difference goes on decreasing with the increase in value of n, because E is directly proportional to 1 by n square. And now the difference, this is not negative, this is a positive difference. Okay, so that is why here the relation is E inversely proportional to n square. So the difference is going to decrease with increase in value of n, whereas the energy itself is going to increase with the value of n. So this is very important. Please do remember and do not commit any mistake. And you can see that we have the values of n and E given. So for N1, this is minus 13.6 electron volt. N2, the energy is minus 3.4 electron volt. So E2 minus E1 is going to be 10.2 electron volt, right? So the difference over here is positive. So the next difference, if you will see, the difference is going to decrease. Here is a chart also that is going to explain all the differences, the relation between the various parameters and nz. So we have the orbit number, we have the radius. So radius is proportional to n square by z. With the increase in the value of z, the radius is going to decrease for the particular orbit. Okay, and for the radii, you can see that with the increase in value of n, the radius is increasing, and the difference of the radii between two successive energy levels, that is also increasing, and the radius is directly proportional to n square. Okay, then velocity, that is proportional to z by n. So with the increase in the value of n, the velocity is decreasing. And this is going to be approaching towards zero as and as away we are going to move from n. Fine. So I hope this is clear. And for increase in the z value, the velocity is going to increase. Similarly, for total energy, we've just now discussed about the z and the n. You can see the difference over here between the different energy levels. So this difference is decreasing. Okay, and the energy state, one important term, the N1 state, that is the ground state where the electron is without gaining or losing any energy. When it gains some energy, it is going to move to the next energy level. So that energy level is called as the first excited state. It gains more energy, it goes into another one level, so that becomes the second excited state, and so on. So the first excited state is going to be N2, when the ground state is N1, N2, N3, and so on. Okay. Now the question, why the energy of electron has negative sign? We have seen that the energy expression is having a negative sign, but why is it so? Let me explain you that. So we have an electron which is at an infinite distance from the nucleus, right? So this means that the n is approaching to infinity. And if n is approaching to infinity, we were seeing that the increase in value of n, the energy of the electron was becoming less and less negative. So this is approaching to zero, right? And similarly, the velocity, that is also approaching to zero. So the electron is at rest. Fine. But the angular momentum is constant. Bohr said that right? So if V is approaching to 0, then R must be approaching to infinity. This also we can say, infer from here also, that if an electron is at rest, the velocity is 0 and mvr is constant, so R must be approaching infinity. So what does this imply in total? That if an electron is free, it is at rest having zero energy, and it is at a far distance from the nucleus. It is having zero electrostatic forces of attraction towards the nucleus, right? And when we are bringing this electron back from infinity close to the nucleus, it is decreasing the number of n. And if it is coming from a higher energy level to a lower energy level to a more energy level, lower energy level, what is it going to do? It is going to lose energy. And if it is losing energy from zero energy, it is going to be negative, right? So that is why it is the energy of an electron that is negative. If you want a write-up for the question, if you are asked in the examination, what you can write is that when the electron is at an infinite distance from the nucleus, there is no electrostatic interaction between the two. Therefore, the energy of the system in this is presumed to be zero. As the electron moves closer to the nucleus, it does some work spending energy for the same. Therefore, the energy of the system goes into negative, that is less than 0, and this negative value will go on increasing as the electron moves to the energy level closer to the nucleus. So I hope this is a very important question and you are clear why the energy of electron has a negative sign. Now, one important expression that we can also calculate is the frequency of revolution of electron in the nth orbit, or the number of revolutions is what I mean from here. How many times in a given time the electron can revolve in the nth orbit. So we know that the frequency of revolution is 1 over time, right? So and time is nothing but distance over speed, and distance for the orbit, because it's a circular orbit, so that is 2 pi r divided by v. Putting the value of v and r, what all we have calculated in our last lecture, we are going to get t to be 2 pi into 0.529 into 10 power minus 10 n square by z, and the value of v 2.165 into 10 power 6 multiplied by z by n, right? So we just inversing that to get the frequency. Frequency is going to be 6.53 into 10 power 15 z square by n cube second inverse. So the frequency of revolution, this is directly proportional to z square and inversely proportional to the cube of the number of the orbit. Alright, so I hope this relation is also clear to you. It is asked sometimes in the examinations. So that would be all for this lecture. I hope you've enjoyed the lecture. You've understood everything that we have been discussing about. In case there is any query, you can mail us at h2ochemistry@gmail.com or put it in the comment section also. We will be definitely trying to help you answer all your queries, right? So please, if you've liked the lecture, do click on the like link. Also do subscribe to our channel H2O and click on the bell icon so that you get a notification as and when we put up a new lecture for you, a new course for you. In the next lecture, we would be discussing the merits of the BOHR'S atomic model. So see you then. Have a nice day. Enjoy your studies. Bye bye.